So one more example of just simply calculating work. Now, in this case, we're given a force. This force has X, Y, and Z components. Don't let that stress you out. The displacement, it's labeled D. We mean delta S as displacement. It has X and Y components. This force is constant. The X component is 60. The Y component is negative 30. The Z component is 20. There's no X, Y, or Z variable in there. So the force is constant, which means we can say the work is the force dotted with displacement. Technically, we could say F delta S cosine theta, where theta is specifically the angle between those two. But I don't want to waste my time finding an angle when I can simply do the dot product. If you remember from an earlier video, doing the dot product is multiplying parallel components. So we will take the X component of the force and multiply that by the X component of the displacement. Then we take the Y component of the force and multiply that by the Y component of the displacement. And similarly for the Z component. So looking at our force vector, the X component, remember I hat means X direction, so the X component of the force is 60 newtons. The X displacement is 2 meters. So that's Fx times delta X. Fy, Y is J, so negative 30 times J over here for the displacement is negative 5. So 30 newtons, 5 meters. In the Z direction, this last term, there is no delta Z. There is no movement in the Z direction. So even though there's a Z component of force, there's no work done by that component. So the total work done will be 120 plus 150. So what, 270 newtons times a meter is a joule. So there is the work done by that specific force as it moves through this specific displacement.